Okay, now we want to look at sections 1.1 through 1.3. So this says part 1, and all your projects will kind of have these 0, 1, 2, however many sections are needed. Here, mostly as far as your work, your main tasks, technical tasks, it's just this section 1, part 1. So the background goes through and mentions this accessibility and access to services. Right here it's mentioning reasonable travel, and yeah, it turns out that distance is kind of important in access, right? If I want to access a service and it's a long way away and takes me a long time to get there, well, I don't know that I would really feel I have that much access to the service. So this is kind of setting up that problem. And so it's important, though, that we talk about distance and what we mean by distance, because in the end, there are really a lot of different ways to define distance. And so here we want to kind of look at those in a contextual fashion. And so we start, that was 1.1, 1.2, just sets up our problem. What we want to do is we're going to go look at the Pikeville Medical Center as our destination or our service location. And we're going to use the Desmos calculator in Google Maps to look at different distances based on definition for 10 locations. Okay, so then 1.3 is Euclidean distance, and so we'll look at that. And in 1.31, definition. So I read this, I need to go through, make sure I get this definition. That, yeah, definition of Euclidean distance is what we think of when we usually think of distance. The shortest, that shortest span between 2 points. I go in a straight line and I ask how far that is. Well, the Pythagorean Theorem tells us that if I have this right triangle, all I need to do is take this leg squared plus that leg squared and add them together and take the square root. And that's what we get from the Pythagorean Theorem. We get that hypotenuse length that way. And so then this is just going through and saying in a little more mathy stuff. Well, okay. So, let's talk about these legs. Where do we get the length of those legs from those 2 points? So I've got a couple points, XA, YA, so maybe that's this point, and XB, YB, maybe that's this point. So I'm reading this, and that length here, the horizontal length, that's saying, well, I just take, say, this X value 1 minus that X value 7. Well, that would give me -6. That's not a distance. Oh, but so we put the absolute values on them. If I had used 7 minus 1, I'd have gotten a +6 and everything would have been fine. But so this is just saying, how would I know that distance is 6? And it would be from those coordinates, the 7 and the 1. And so that's all that's showing us. Similarly, vertically, all this is showing us is how would I get that 3 that I see up here? Well, I would take that 5 and that 2. I'd take 5 minus 2, or I'd take 2 minus 5. But since 2 minus 5 gives you a -3, we need to make sure we use those absolute values. So those would be the legs, and then the Pythagorean Theorem, all that says is that the hypotenuse squared plus leg 1 squared plus leg 2 squared, well, hypotenuse squared is equal to those. If I take the square root of both sides, that's where I'm getting that Pythagorean Theorem idea this way with the square root. And if I change that into, what I did up here with the YA minus YB and XA minus XB, that length of that leg is XA minus XB squared. Now I got rid of absolute values because when I square, I get an absolute value. I get a positive number. And so this is just saying that if I want the distance, the Euclidean distance, I used a dE distance, for D for distance, E for Euclidean. For 2 points A and B, I can get that with that formula. And then using those points 1, 2, and 7, 5, I put that in, and sure enough, we get the 6.708. That one, if you really wanted to measure and get the right measuring stick that had these units, you would see that yes, that's 6.708. Okay, so that's all background, making sure we all believe and know what Euclidean distance is. And then you get into these things of tasks. So here's task 1.1. Now again, it's really your first task. The one, though, is the first one is letting us know it's in section 1. And it says open Desmos and sign in if you don't already have it open. Well, I have it open right there. Oh, lights went off. I guess I'm not animated enough, so see, I'll do that and lights will come back on. Okay, so then it says in the first input cell, enter the point A12, and then it shows you the figure. So see, I'm not going to have videos like this for all your projects, but this, I'm trying to show you how these projects are set up, and they're hopefully not bad. As far as I think you can follow them and so forth. Now, an important thing I'm going to point out is, see, I tell you here what I want you to do, and then I say look at figure 1 to help you. That's why I put in the figure, is to help the reader. And I named the figure 1.2, so you could find it. Okay, I just didn't put in a picture without any reference. You should do the same thing. And so when you add a picture, you should give it a little caption like this, give it a number, and in the typing, when you're talking to the reader, tell them what they're supposed to be looking for. So it says put in A equal 1, 2. So put in that point, and see, I just have it there. So I go here and I type A equals 1, 2, and hit enter. And now I didn't actually have to hit enter for Desmos to know what I had just done, but it's just helpful. Now you're looking at this on the screen. To help you see it, there is a nice thing you can do with Desmos. I can click here on the graph settings. Under display, I can click that A, and it makes everything a little more bold and so forth. And there are other things I can do here. I can change the axis manually and so forth. But of course I can do that by zooming in and zooming out and with my mouse wheel. Or here's a zoom out in and a zoom out there. Okay, so I did that. And then I go back here. So see, that wasn't such a bad task. And then it says, oh, check the label. So I checked the label. And notice it added the 1, 2 there. And then it says make that label read A. And so I go here and I type an A, and all of a sudden that label changed to an A. Okay, so I have the points. Then notice it just says, so I led you through each of those 3 sub-steps to get that. Then I just say, oh, add and label the point B. And then I show you a picture here of what I want. And so B is 7, 5. And so I type in B equals, whoops, I missed the open parenthesis. There we go, 7, 5. Like that. I'll label it, call it B, and there you see it. Okay, and I can hit enter. Well, or I can do that, click down there. And there I have those. And then it says in the third input cell, put the command distance AB. So that's, yeah, just distance and AB. So I do that. Whoops, got to spell it right. And notice, see how it's saying add slider and so forth? It just thinks I'm typing letters that I might want to use as variables until I get the whole word distance. And then you see it makes it nice type and doesn't try to ask me to add sliders. At some point we'll see what sliders are and all that. And then A, comma, B, and parenthesis. And there's my 6.708. Awesome. Now, so that's one way I can get a Euclidean distance from Desmos. Another way is I could say distance and I could use the points, and that's what it's telling us to do here. So, I just type in distance again. And then I use the points, open parenthesis. Now I need to do the points, and I say 1, 2, close parenthesis, comma, 7, 5, close parenthesis like that, and you see I get the same answer. And so that's another way. And then finally, I look here, that was task 1.7, then task 1.8. It just says, oh, type D equals. Now, I don't actually need the D equals, but it's probably not a bad idea to name things in here. And so I'm going to just type in that Pythagorean Theorem idea. So I'm going to tell it, okay, D equals. Now, square root. You can go down here. Here's the show keypad, and there's a square root. And then you see it's under there, and I could start typing. And there are parentheses and numbers and all that. I find that the keyboard works just fine. So another thing you can do is start typing SQR. Now, as soon as I do a T, it made a square root symbol. So I did SQRT, and it made a square root symbol. Then I just do the open parenthesis 1 minus 7 for the x's. Now I need to square it. And right now it's saying it's undefined because that's a negative number and I can't take the square root of a negative number. So again, to square it, I could go here and see I could say a squared. And it made the square. And now it's defined. Okay, or I'm there. If I do an up arrow, which is over the 6, it changed that a little bit. It put me up in the superscript, and now I type a 2, and I can make a square that way. Now, notice the cursor is up by the 2. I have to do a right arrow or click or something like that to get out of there. And then I say plus. Now, in some things, so let me go back to there. Now, I'm going to, without doing the arrow, I'm going to do a plus. And see, it said, oh, you want to add something to it. So if I had wanted a plus up in the exponent, I probably would have needed to use some parentheses or something. So sometimes, just like any technology, Desmos can get a little frustrating at times before you figure out some of these ideas. So there's the 2 minus 5. I'll do my up arrow again, do the 2, and I'll hit enter. And there's my 6.7082 and so forth. So same thing. So any of those methods are fine. I don't care. Okay, at least at this point for finding a Euclidean distance, because any of them are fine. What you might do is try each of the 3, with some practice points and so forth. Okay, so I've done that. There's my task 1.8. Now it says change this, edit the thing to do the points -3, 6, and 4, -8. Okay, minus 3, 6, and 4, negative 8. So see, all I have to do is go in here and go minus 3, comma 6, 4, comma negative 8. Now, that fixed this one, right? That automatically, because this was called A and B, and I used A and B here, that automatically just changed that and gave me 15.65. These didn't change. Now, I could go in here and edit this one thing at a time, or now if I come up here and if I, well, actually all I need are the numbers, and I highlight the negative 3 and 6, and then on my keyboard hold down Control and hit C, do a Control C for copy, and then come in here and highlight that and do a Control V. I can copy and paste that way. So I could use copy and paste. Now a right click kind of thing to copy and paste doesn't work. You see it's doing web stuff, save page as and all that. So that doesn't work. Or I could just, come in here, highlight it to get rid of it, backspace, and then go 4, comma, negative 8. But I have to edit, all of these things. So then here, negative 3 minus 4. Oops, I said 4, type 7. That's weird. Minus 3, and then a minus 4, and then 6. Minus a negative 8. And so I can write it that way, minus a negative 8, and you see I get 15.65. So all of those match. I must have done it right. And then I go back here and it says save a screenshot of your graph. Okay, so screenshot. Now I have some videos on stuff like this, but here I'll do it in this first one. Now of course I've got me showing here, and you wouldn't have that. Now the other thing is I can only see point A, so here I'm gonna pull this down or something. Well, I'll zoom out a little bit. Oh, there's point B. Okay, I get 4, negative 8. Yeah, sure, 4 and then down 8. So I had to zoom and pan a little bit to make the picture look okay. But there we go. There it is. And now I need to get a screenshot of this. The easiest thing to do for Desmos is use Control Print Screen. And again, I have a video on this, but I'm going to do it right here. I'm going to hold down my Control key and go up, and there's a PRTSC key way up at the top row, Print Screen, and I do that. Oh wait, before I do that, my speakers are not on. I'm going to put that speaker on because when I do this, I think you're going to hear a camera click. Something that sounds like a, well, yeah, I guess your phones make camera clicks. So I hit print screen, and you saw it did something, and it made it sound like I took a picture. And so now, remember I had made this document. So since I'm supposed to get a screenshot, what I'm going to do is just come down here, and I'm going to paste my screenshot. So when I did that print screen, it copied it to the copy buffer, and if I say paste, look at that. There it is. Now, I don't want all that. I really just want the Desmos stuff. And what I can do is most of you have some kind of edit capability within Word. I don't tend to use Word, so mine doesn't look the same. But somewhere, and I think, yeah, here's mine, is crop image. And when I click that, I get these squares and so forth. And what I want to do is I'm going to bring this one in so that stuff on the right hand side doesn't show. and I'm going to grab that one and bring it in so it only shows decimals. But see, there's my name. And now, I'd really like to show the points. And so if I didn't like that, I could zoom out enough that I could still see these points and maybe move it up where I could crop the bottom here, but I can't really crop the bottom. So that's good. So that's where I'm going to crop it, is to there. And then I'll just click, and it's been cropped. And now, though, I can also click on it and say, that seems a little big. And if I grab one of the corners, that's a better thing to do, because that'll keep what we call the aspect ratio the same. And so there, it's not quite so big, but I can still read it. Heck, I could probably make it even a little smaller. And, move it over here more toward the center. And there we go. Well, that's not really centered. Okay, there's a nice picture. Okay, so I've got that picture. And what I might actually do is go ahead here and oh, I guess let's see, enter. Where am I now? Not sure where I am. Oh, there it is. I'm over on the edge over there. Okay, now I'm here. I might just, for now, I'm going to call this figure 1. And this is something like Desmos and Euclidean distance, so maybe that's my figure name. And then, here, well, and I'll hit enter and maybe come down a little bit. You all are hopefully much better at Word than I am, because I don't tend to use it. But here I'll center that, so there's a nice figure caption that goes with my first figure. Okay, so I added that as I've gone, and it's in my document because I'd already made my document. And so now I can go back here, and it says, oh, save this, because you might want it later. So I can say save, and I'm suggesting something like, math 1003. Now notice when I'm saving it, see, this is stuff I've saved in the past for math 1003. And it keeps that there, and we'll look at where it keeps it and all that here in a moment. But math 103. And is that what I said? Yeah, and then I said distance, so that's what I'll use. Well, if I could spell it. Okay, and I say save, and notice it's up there, and here that is save, but it's kind of not there because I don't need to, because I just saved it. But now over here, these lines, open a graph. Here are all my things. I've got a bunch of things saved. You'll have this math 103, and you can search. See, it says search. Yeah, I could search my graphs. That's why I suggested doing math 103. But now if I click back out here, it just closes up. So that's why you might want to save things. And so there, I've saved it, so I can come back to it another time. Okay, and then the Euclidean distance and context. So we keep going with our Euclidean distance. And here this says open the prepared graph, Desmos graph here. And I already have that open. Now again, when you open it, you probably want to open it in a new tab. It's coming up here, and there it is. And what you see is it's a map that I could put in Desmos, and I can add something like an image. So here's how I added it. I said add an image, and it was this picture here, Pikeville Med Center scale and so forth. So I had it with a scale, and so I had to do a little work to make this happen, and that's where you see things like the height and the center and the width and so forth. So I had to play with the picture a little bit to get it the right scale, but the nice part is you see where that says 2, well that's actually 2 miles from the Pikeville Medical Center right there. Straight across, that's 2 miles. That's 2 miles up there. That's 4 miles right there, so because it's at -4. So I did that, and I plotted the points of these 10 different locations, and it starts here at Clevenser's branch and goes in a clockwise fashion to keep things kind of organized. And so we opened that. Okay, we did that. And it should look like this, it says, and it does. Okay, and here's a little explanation about it. Okay, it says click in the second cell for the Clevenger's branch and hit the enter to create an empty cell below it. So I come in here, I'll click there, I'll hit enter, empty cell. And then it says calculate the Euclidean distance using any method you want. Okay, so now the thing is Euclidean distance from the Pikeville Medical Center, but that's at 0, 0. So as I do that, probably for me the easiest thing is I just say square root, and then I do the 0 minus 0 squared, and then plus 5 minus 0 squared. And sure enough, you know, it's up here at 0, 5. Yes, that should be a distance of 5 away from the origin. That's easy. I can do that one. I can do this one down here. I'll be able to do that. What I can't do are these that are off at an angle. So I do that, and I get the answer they're looking for, 5. Now, I didn't have to do it this way. You know, I could have come up here and, you know, said, okay, this is A equals, and labeled it. And let's see what my picture is here. See, and I could use the distance thing and say A, from A to 0, 0. Now, I didn't name the origin. I guess I could have done that as well, but you know, so here I could say distance from A to 0, 0, whoops, comma. I'm still having trouble. There we go, comma, 0. There we go. Oh, I've got something on my screen. I thought I typed a semicolon. I've got a dot on my screen. You can't see it. Okay, so, you know, distance, and I get 5. Now, I'm going to, there's also, if you mess things up and so forth, there's some undos. So I'm going to undo, I guess, a lot. But just to show you can undo. And I'm going to go back to this one. That's the one I'm going to use. Okay, and then so I did that, and you know, it just says calculate one of these ways, and then do the same thing for Zebulon. Okay, and calculate that. So I'm going to go here. Oops, wrong place. That's our course. I'm going to click in here, hit enter. Now, again, I could type square root and so forth, but actually I can, you know, highlight that whole thing, do a Control C and a Control V, put that in there, and then do my 2.95, and 4.05. And there we have it, 5.01. Okay, so I've got that distance. And so I have that. And then it says calculate that Euclidean distance for all 10 locations. Oh, okay. So I would do that. Now I'm actually not going to do that, partly so you have something to do, and partly so you're not simply seeing everything I do, and for time. But let me go down here, because then it says, okay, once I've done that, save a screenshot showing at least the last two locations, Osborne and Mossy Bottom Bridge. Okay, so I would have to put one in here, and that would be a square root of stuff. And notice I'm getting a warning. And again here, square root of stuff. And so I have that. And so I need to at least show those last two. And of course, if I had done these, I would have had stuff in all of these. And so to show those last two, though, I have to take this and kind of get it to where they all show. So they're all showing. Now, how much here shows, I don't care, as long as you've got that. And now we do that same thing again. Control print screen. Took another picture. I go to my document. And I get down here, I give a little space, and again I say paste, and there it is. And I do that same thing again. I'll crop it both this way and this way. So there, it's the size I want. I just click outside of it, and now I can again reduce the size. Get it up here centered somewhere. Kind of look at where I am, where the cursor will be. So, I have that kind of stuff. And then on that one, again, I enter and get down here to where I'm going to put more text. I'm going to have a figure 2, and that was Euclidean distances from 10 locations. And again, I'll probably hit enter and come down here, so not everything gets centered. Like I say, I'm not very good with this kind of thing, so so I have that, and I have room to type stuff in between and type stuff ahead of time and so forth. So I've got those pictures. So then I go back to the project, and it says finally task 119, start a table of locations. So I'm going to need a table like this. Now I think the easiest thing to do is open up your spreadsheet, Microsoft Excel. I already did that, and here I typed in location, all the 10 different locations like that. Let's go back here, and then Euclidean miles, grid miles, and so forth. So I put those columns in like that, and so then I can input my 5 and my 5.01, and I'll have a bunch more to enter. Now I can tell you right off, whoops, I gotta look here, that 360 Hughes Road, well, let's go find that. Yeah, that's at 0, -5. Well, I can tell you the answer to that is 5. So, I could add that right now. 5. And so I've got that much, and I notice if you look up here, I've saved this thing already. So then I can just say save, and I've got this saved. I put in all my distances, and I can make this look nicer. Like this looks good, but this stuff probably ought to all be centered. So I'm going to highlight all that and center it. That looks so much better, right? And I fill those in. And okay, so if, and we'll have to go back and look, but if I need to then add this, even just part of it, so suppose I highlight those and I copy. Now I can come over to my document, wherever my document was, and I can come in here, and again, I can say something like, oh, this is going to be table, and I go with this. I go 3 because my figure was 2, table 3, Euclidean distances. Now that's a very similar name, I realize, to that, so maybe I would want to then come up here and do something like Desmos Euclidean distances, something like that, just to make the titles a little bit different. And so there I have that. I'll hit enter. Ooh, that's now okay, and I'll do a paste. And there's the table, just like that. Now, if you turn this in, that's a piece of crap. Okay, that's hard to read, right? So hit enter, put it on the next page, and then if we, well, I guess I have to come down here to get farther down. But so I've entered that. I can take this part and again center it. Now again, you don't have to do exactly like I do, in that I put figure captions under the figure and I put table captions over the table. At some point I learned that in some sort of style manual. You don't have to do it. You could do them all on top or all on bottom, but whatever. But there, you see I've got my table. Now you would have all your numbers in there, but you'd have your table. And okay, we go back here, and there we go. We're done, at least with our technical work for 1.3. So I will stop this there.